flipping to?
The terms sheet.
Yep, we're going to be doing perpendicular lines. This is the second section. We have some new rules, and the reason I'm calling them rules is because sometimes they're postulates and sometimes they're theorems, and so it's just easier for that. All right. The first one we're going to do is the congruent linear pair theorem. You have it on there already. It says, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. I personally think it would be really good for you to draw pictures of these right next door in those term sheets. It is optional. If you draw pictures here, when you put them in your postulate book, you'll have a picture. And when you're doing proofs, if you have a picture to look at, sometimes if that picture is similar to what you have in your proof, it'll trigger an idea in your head. So the if part is the picture that I'm going to be drawing. So if I have two lines intersect to form a linear pair of congruent angles, so I'm going to have a line, and my other line has to intersect and be linear pairs, and they have to be congruent. So what kind of line do I have to draw?
A 90-degree angle.
I have to draw a 90-degree angle because this angle here has to be congruent to that one. If I would have drawn it slanted, these two angles would not have been equal. I have to draw a 90 degrees on both sides. The only way it works. And that is exactly what the theorem said. It said that if two lines intersect to form a linear pair of congruent angles, if these are congruent, it has to be perpendicular. I'm going to do some different colors so I can write that better. Congruent, it must be perpendicular. Okay? Number 2. Oh, wait. Sorry.
Did I do that model or is that supposed to be like that too?
Sure. I made these curved on purpose. I actually should have, so that
like,
they would look like congruent and not. There we go. You understand? And then I made this one so that it would make them look congruent.
So they're congruent.
They're congruent and they're linear pairs. So congruent and linear pair have to be, because it's got to be 90 plus 90 to equal 180, right?
Yeah.
Okay. Number 2. I already drew it. Put it on your sheets. Okay, here we go. Adjacent perpendicular angle theorem. You should see that on your page there already. And there's room to draw next to it. This is what it says. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So I have to have adjacent and acute. So I have to have that one, right? Oh, I have to be acute. That's up 2. So I have to go like that. And it's got to be perpendicular now. It has to be perpendicular. Let me draw my perpendicular. These, number 1 and number 2, these are both acute angles. The lines that I drew were perpendicular. So what do you know about 1 and 2? They have to add up to how much?
90.
They have to add up to 90 because of the adjacent perpendicular angle theorem. So I could write as a little example, and you'd be able to write this in your postulate book, that angle 1 plus angle 2 have to add up to be 90 degrees. They have to be, because they're acute, they're adjacent, and these are perpendicular. It has to be 90. If you draw those pictures, a lot of times it's going to just, when you're doing a problem or a proof, it'll say, oh, that looks like a picture I drew in my postulate book. Wonder if I can use it. I did it already. Number 3. The last one that we're going to be drawing is called the perpendicular 4 right angles theorem. And, by the way, I want to show you something really cool because everybody loves to abbreviate. Instead of you writing that big long word perpendicular, that is the symbol for perpendicular. It's just, did we talk about this before, I think?
We talked about
so it's
it,
the
yeah.
upside down T.
Mm-hmm.
And so if you're using this in a proof, you can just write the perpendicular 4. You can do write RT if you want, and angles, so you can shorten that a lot. Okay. All right. if two lines are perpendicular, I'm going to stop there. I'll draw. If two lines are perpendicular, it says, those are decently perpendicular. It says that they form how many right angles?
4.
4 right angles. That's what it means to be perpendicular, almost. It's almost like the definition of perpendicular. All right? This one's going to be vertical. It's going to be right across, so it has to be 90, right? And these two are adjacent, so they have to be 90. So that, and then the vertical again, we've got 4 right angles. 1, 2, 3, 4. Okay. All right. We drew it already. What should we draw? Now, we're going to do some examples, but we're going to do half of number 1 on your homework. Half of number 1 on your homework. So go to 3.2. 3.2, the very first one, I tried really hard to make it so that it'd be upright instead of all these sideways pages. I've got a diagram at the top up there. I'll bring it up on here. You can see it. Based on those theorems, so if you want to have your hand inside your postulate in that terms so that you'll know what the reason is, because right here there's going to be a definition, a postulate, or a theorem that goes in here. The top 4 are multiple choice. The bottom 4 you have to write the answer in. The question is, if AC is perpendicular to BC, what kind of angle is ACB? So we have to do that one first. So I'm going to mark my diagram. We said that AC is perpendicular to BC. That's right there. And ACB is right there. What kind of angle does it have to be? A right angle. Why? What's the definition? Postulate, theorem, and I'm going to tell you something from today.
Didn't we just do it?
We just did it. That's right. We just did it.
Perpendicular.
Perpendicular.
Adjacent.
Adjacent perpendicular.
Adjacent perpendicular. It says that. That one says that we add two things together to make them complementary, correct? And we're not saying anything about complementary.
If two, that's the perpendicular 4 right angles.
That's correct. It's the perpendicular 4 right angles.
Perpendicular and they intersect.
So I'm going to abbreviate that. Perpendicular. Oh, no, wrong.
Are there 4?
There are.
Oh,
And well, at least one of them is. If we don't say that all 4 of them, but we're saying that if it's. Oh, wait a second. Wait.
There's
There
not.
are,
No.
There are 4 there.
There aren't 4, but if it's perpendicular and that means it's right, correct?
Yes.
Wouldn't that be? We're not saying that all 4 of them are. We're only saying one of them is.
Yeah.
So maybe it's a definition.
Definition of perpendicular?
Yes.
Definitely.
All right. I think that I would have also. I don't know. That's right. You're right. We're not saying that all 4 of them are. All right. The second one down. It's not really number 2 because this is all number 1. If AC is perpendicular to BC, same we have up there, right? What do we know about angle 1 and 2? This time we're doing angle.
AC.
Are they congruent? Are they complementary? Are they supplementary?
Complementary.
They're complementary. How in the world can we say that?
That's the adjacent.
There could be, you could put 2 in here for that reason, but for sure it's the
Adjacent perpendicular angle theorem.
the adjacent perpendicular angle theorem. But for this one, if this is right, this one has to be right.
Linear pair.
So then it's
Linear pair function.
yeah, but you have to do the one about it being complementary. But if you wanted those people who want to write all the other parts of it, you'll need to either be linear pair or the one that said that there are 4 right angles to that perpendicular 4 right angles theorem. But we said that it was the. Tell me what the name of that one was. The what?
Adjacent.
Perpendicular. Yes, adjacent.
Oh,
Adjacent perpendicular. Nope, wrong thing. Perpendicular is upside down. Adjacent perpendicular angles.
Theorem.
angle theorem.
Yeah, okay. with the little angles. All right, next one. If GE bisects DEC, what do you know about angle 3 and 4? That's right, here. If something bisects, does that make them complementary, supplementary, or congruent?
Like,
What does that mean to bisect something?
oh, it cuts them into half.
Cuts them into half,
so
or
complementary.
so it would they be complementary if it cuts them in half?
No, I meant congruent, sorry.
Congruent. And what would the reason be?
Definition of bisect.
Congruent linear pair theorem.
Because these are not linear pairs.
Oh, okay.
Yeah. It would be the definition of bisect. Yes, I know. This is the last one. Except I think, yep, we are. Okay. All right, last one. If ACB is congruent to BCE, then those rays, I can't tell very well, is those rays. What do we know about ray?
Do you mean B C E?
Yeah, that's what she said.
Oh, I thought she said D C E.
I'm sorry, BCE. What do we know about BC, ray BC, and line AF? Are they congruent, supplementary, or perpendicular? If we just went with process of elimination, can a ray and a line be congruent? They go on forever. So they're naturally the same length because they're infinite long. So that wouldn't make sense. Can lines be supplementary? What kind of things are supplementary? Things that add up to 180 degrees. And what kind of things add up to 180 degrees? Lines or angles. So they can't be supplementary, can they? So they're going to have to be process of elimination. They're going to have to be perpendicular. So at least by a process of elimination. So if it says that these two, I'm going to erase my marks up here. It says that these two are congruent. Why do they have to be perpendicular? Why do those lines that ray and line have to be perpendicular? We know they're linear pairs, by the way. We know that those two red marks that I said were linear pairs. So if you have something about if something's a linear pair and they're right next to each other, what's the word for right next to each other? Adjacent. Do you have anything about adjacent and linear pair? Of the things we studied today? If two...
Congruent linear pair theorem.
The congruent linear pair postular theorem.
Yeah.
So I'm going to abbreviate congruent linear pair. You can put theorem if you want. All right, we did half of it. Now the second half, notice it's not multiple choice on your answers, but I at least started it off for you so that you kind of get an idea what you're doing. Okay. All right. For this section, you learned 3 new theorems, and we applied them. You will have a proof, only one of all the 3 days. There's only one, not one each day, just one period. Okay? We're done. Have a fantastic day.